Hello everyone, I hope you are all doing great. Welcome to this new video where we are going to go through construct string from binary tree. So basically what we have here is that we receive as input a binary tree and we are supposed to construct a string from the binary tree using the in-order traversal, the pre-order traversal I mean. So what does that mean exactly? That means, okay, for such a tree we are supposed to transform this into string. So using the pre-order traversal, that means you read the root first, then you read the left, then you read the right. So for an element like this, you are going to read this one, which is actually 1, then you are going to open parenthesis, read the 2, you open again parenthesis, you read the 4, you close the parenthesis. You have done now with the left, now you go to the right, you read the right element. So this is actually what we are supposed to do. So let me just show you here so you can understand better. Let's say you have this example. For you to represent this, you are going to start by putting the element. Once you put the element, you open your bracket. In your bracket, you first put the left element. After, you open again a bracket, and in this one you put the right element. If you see the problem like this, it cannot help you to do it like more easily. So this is actually the first level. Now for the left, what will it look like? If you want to see the left now, let me take another color. So the left will be, you put the value which is actually 4, and then you open for the left, you put the left here, and then you open for the right, you put the right here. You see where I'm going? So if I'm taking this again, let me take another color. So it left will be, the left of 4 will be this guy. So you actually put the 9, and then the right will be the 6. So you actually put the 6. So let me take another color, this time color that we are going to see. So you can see that this one, let us ignore this one will be as, this one will give you something like, you are going to have the 1, you open the parenthesis, in the parenthesis you were having the left, which is actually this, which is actually the 4, and in the parenthesis of the 4 you were having another left, which is actually the 9, and then you have another one here, which is actually the right, which was the 6, and then you have this closing tag. You see what has been happened? So just by saying, okay, for each of the element, I put the element, then I loop through the left and I loop through the right, you'll be able to construct the string. Let us see what the implementation will look like. So if you want to implement such approach, what are you going to do? The first thing you need to do is, you remember that when we were here, we did nothing, like, because we don't have left children, we don't have right children. So when the node is actually null, you do nothing. So that is what you're going to start here. When you are trying to work with recursion, the first thing you need to remember is, what is the breaking stage, what is the base stage, and in this case is, if the root is actually equal to null, you just return empty string, nothing. And then now you can dive into your logic. Now your logic, you can just define string, you can just define the result, which is equal to, now you know that you always start by the value, so you just need to put it like this, to string of root dot val. Now you have a left which may be empty, and then you have a right which may be also empty. And from this you are going to say, okay, if the root dot right does exist, no, in the pre-order traversal we always start with the left first. If the left exists, what you're going to do is that you're just going to say result plus equal to, now remember we started with the value, and then now if the left exists, we are just going to put the left. So you're just going to put something like this, plus the tree to string. So we call the function of the root dot left plus, then we close our tab, we close our parentheses. So this is what I've been doing here. I open the parentheses, I put the content of the left, and I close the parentheses. This is what we have here. And then the same for the right. I'm just gonna copy paste here. So the same for the right. We are gonna say, okay, we are going to put the right if it exists, and then here we just return the result. So this is actually a solution, but it will not pass all the test cases. Why? Because there's something interesting that has been said here. So let me run, you will see. Let me run, you will see. I made an error somewhere. Oh, oh, okay, it's not good. So this is how you write it. Okay. Oh my god, what is happening? Tree to string. Oh man, it's not tree to string, it's tree to this. Okay, you see that this one is actually passing, but this one is not passing. Why? Because in this second one we omitted the empty parentheses, and then it has been stated here you can't omit these parentheses to not break the one-to-one mapping. So when you have a left, you put the value. When you have a right, you put the value. But if you don't have a left but you have a right, you should put empty string here. If you have a left or if you have a right, you should always put something. By doing this, you will be able to handle this condition, because if you have a right and then left does not exist, these two strings will actually return an empty string, and then this one will be empty parentheses. It will actually not break the one-to-one mapping. So for you to handle this case, you need to make sure that if the right exists and the left doesn't exist, you still return empty parentheses. Let's just run and see. You can see that now everything is green. Let us submit. You have everything green. So this is my approach of solving this. I hope you do enjoy it. Feel free to leave me any input. I'll be really happy to interact with you regarding this. See you on the next video. Ciao.